Hello, this is Founders Pod. I'm Lilith, the founder of Founders Investment Syndicate that are focusing on the Canadian early stage technology companies. So, through my journey in venture capital space, I've met a lot of incredible people. They're the ones reshaping our world with the disruptive technologies, and I'm just so excited to bring their stories right to you. So, in this podcast, we'll chat with the innovators, founders, and masters and experts, each with the unique stories and insights that are just too good to keep to ourselves. So this is all about sharing real human stories behind the latest technology innovations and understanding the rapid changes in our tech world. So grab a coffee, relax, and join us as we're diving into these conversations. Oh, and hey, if you want to know more about what we're building, swing by founders.com. So now let's get started. Hi guys, welcome to Founders Pod. Following my conversation with Raymond Chik, the co-founder of Untether AI, as a semiconductor engineer and multi-time founder. Untether AI provides ultra-efficient, high-performance AI chips to enable new frontiers in AI applications. It is founded by CPPIB, GM Ventures, Intel Capital, Radical Ventures, and Tracker Capital. We've also touched on the future of Moore's Law in the context of evolving semiconductor technology. We've also explored Raymond's view on the shortage of Invidia's AI chips. Additionally, Raymond, as an angel investor, has also shared his perspective on the investing into tech startups and some of his successful investment experiences. Hey Raymond, it's great to meet you, and also at the events recently with Matt. Glad you are coming back to Toronto. So just to give everyone a bit of context about Raymond. So Raymond is the co-founder of Untether AI. So Untether AI provides a ultra-efficient, high-performance AI chips to enable new frontiers in AI applications. And this company is founded by CPPIB, GM Ventures, Intel Capital, Radical Ventures, and Tracker Capital. So to kick things off, Raymond, can you just share a little bit about your journey with us?
Sure. I'm a trained chip design engineer. So my career at the beginning is a bit boring because I came here to study from Hong Kong when I was a teenager, like a lot of people back in the 80s. Did my university, did my graduate degrees in the electrical engineering discipline. I specialized in electronics, and which naturally led me into semiconductor design. I'm designing chips at the transistor level, if you will. And then it's sort of like a cruise control. After I got my PhD, I found a job working for a company designing chips. At the beginning, I was designing memory chips, and then went on to joining a company called Quantum Disk Drives, doing read channel chips. If you it's a bit of a jargon, but it's chip living inside your disk drives, hard disk drives. So cruise control, just design based on what I've learned from school. Everything was smooth and fine and dandy until at one point, not too far from when I left university, maybe 3 or 4 years afterwards, I wouldn't say I got laid off, but the company that I worked for decided to close down the Toronto office and offered five of us when I was there. The company, by the way, the company was called Cadence Design Systems. A lot, if people are in the semiconductor industry, will definitely know this name. They are one of the largest CAD tool suppliers, computer aided design tool suppliers for chip designers. But anyhow, they had a design center in Toronto. I joined. We were five people. We were in a 70 seat space, ready to expand because the division that I was in was doing well, but the whole company wasn't doing so great at that particular quarter, and they want to cut back all the smaller offices. So 3 months after I joined, they say, "Hey, we're going to close it down. You want to come down to the States and join us?" And I said, "Thank you very much." No, because I wanted to stay in Toronto, and the whole team within that Toronto office wanted to stay in Toronto. That's why they joined the Toronto office. So I was out of the job. But being in the industry I wasn't in the industry for too long, but being within the community, especially the U of T community in the semiconductor sort of a space, news travels fast. And a couple of professors that I knew back from U of T called me up and asked me if I wanted to join their brand new startup company. And that was the start of my startup career, if you will. That was back in 1999. So that company was called Snowbush Microelectronics, and founded by Ken Martin and David Johns, both U of T professors. I knew them back in the days, and they called me up because they knew that I was available. And so the most interesting thing about that story was that they were two pretty well-known professors in the field, so they were able to secure a design contract with Fairchild Semiconductor back in down in the States. But when I said secure, they haven't really secured because they didn't have anyone working full time on the project, being professors, right?
Yes,
So
yes.
that's kind of how I slotted in the picture. But then I said, okay, if you need someone to work full time, I don't mind working as founding employee, if you will. It basically was just those two guys as founders, and then they called me up. And then, is there a project there? He said, yes, there's a project there, but the person responsible, the director responsible for farming out the project to this company, the small company, Snowbush, wanted to make sure that there's someone working on it full time. So he and I got on the phone. Still remember that was before Christmas, about the same time here. And he said, hey, are you going to work full time? And I said, are you going to give us the project? And he said, yes, if you're going to work full time, I'll give you the project. And I said, okay, if you give us the project, I'll work full time. And that's really how the company sort of had started with their first project. Really, that's kind of kickstarted my startup career. And fast forward, the company exited 7 or 8 years down the road. And then I joined another startup with a U of T professor. And then I started my own company with another U of T professor. And that actually spun off Untether AI 6 years ago.
Wow, you have a really, what I say, experience journey within entrepreneurship innovation system here. I have a question here. Do you think you consider yourself more of a engineer side person or a more of a commercializing entrepreneur side person? I know you have a engineer background, but it seems like
Yeah, I think I call myself engineer first. So I still wear my iron ring, if you know what that is.
please introduce me.
This is an iron ring that is given to all engineering graduates in the Canadian university system. This is to sort of remind yourself to be ethical and moral and do good to the human nature as an engineer. In short, you can Google up what iron ring means.
Yeah, definitely.
Yeah.
This is interesting.
So they do when I got my bachelor's degree, they have a ritual of a calling of an engineer where they put all the graduates inside a sort of a big hall. Only engineers are allowed in that hall to sort of before graduation. That's another ceremony. It's got a secret ceremony. It's kind of old school, but yeah, that's something that it seems even a bigger deal than getting the graduation ceremony.
Wow.
But anyhow, that's Canadian engineers with iron rings. So I'm still proud of being an engineer. So that's why I call myself an engineer first. And then entrepreneur, obviously, serial entrepreneur. I've done multiple startups. And so I do have some experience in sales, and I don't call myself a salesman, but I have to go out and do sales call in one of my previous companies as an engineer. So we sell design services, so I need to go out and call customers, travel to Japan, Asia, and China, and different places. And then recently, I started angel investing.
Yes.
For the past 3 or 4 years. I've started investing in startups like 8, 9 years ago, but that was sporadic, opportunistic, not really sort of regularly doing it. But in the last 3 or 4 years, I've started sort of regularly doing it and getting more involved in the community and in the startup ecosystem around the area.
Yeah, I'm so happy to talk about that as well. So, but before let's talk about your angel investing experiences. So you're known as the co-founder of Untether AI. Just I've done some introductions about that. So could you please share with us a bit about what you're building now, and also basically what you're trying to achieve within Untether AI, and some of the context about the markets and the problem that you're solving would be appreciated as well.
Sure. Untether AI is a fabless semiconductor company. As if you introduced, we do chips primarily. Fabless being we don't manufacture. And nowadays, probably over the past 5 years or so, people are starting to understand our industry. People talk about Taiwan, TSMC Semiconductor Manufacturing Company. That's a term that nobody knew probably. I mean, nobody means average person. And I tell my mom, my dad, they don't know what I was talking about. But nowadays, when I talk to everybody, seems to know the jargons and the industry. But anyhow, so TSMC manufactures our chips. As with it's kind of like most fabless semiconductors use TSMC. That's not the only foundry, but that's the one that I have worked for almost 30 years with. And our chip basically does AI acceleration, specifically for inference. I don't know if people, well, the layman knows what inference is, but in short, when you do AI, you've heard a lot about training,
Yes.
teaching the model and training the ChatGPT 3.5, 4 large language model and whatnot. That's training up using heavy duty compute power to train up a model to be intelligent.
Yes.
And once you train them up, you deploy them. The way you use a ChatGPT online and chat with it, that's the action of deployment and what we call that inference. So it's less compute intensive than training, but it's very widespread because once you train a model, you have to deploy it. People use it basically, right? So use it in autonomous in your EV and your autonomous driving. You have a lot of inference going on, meaning that you're deploying the intelligence, the model, to be able to recognize an object, recognize a bicycle, recognize a person, or recognize a paper flowing in front of the car, whether it stops or not. So that kind of an intelligence is inference, and therefore it's very widespread. And we, Untether AI, as when we started the company, we decided that even knowing that training is big, but we wanted to tackle the problem coming down the road where the deployment is going to be massive down the road. Right. So, and also, frankly, the inference compute architecture is a little simpler than training. So it's easier for a small company to tackle. And we've got some trick up our sleeves when we first started the company to sort of, I would like to call it revolutionize the compute architecture to be able to do inference extremely efficiently from a power energy perspective. And in fact, well, that's kind of how we started the company. And the energy efficient theme hasn't changed. So we've always designed we've always done our R&D based on the fact that we needed to develop having new generations of devices, one over another, to be more and more power efficient. And that's the theme of the company. And in fact, basic idea behind our architecture to make our architecture very power efficient. By the way, we're branding our architecture called at memory architecture. That idea actually came from my co-founder, Martin Snellgrove, whom I've worked with for about the past 20 years, based on his research at U of T when he was a professor there, like 25, 30 years ago. So the idea was there, generated a bunch of papers and PhD theses, but that was an idea that was too early. It wasn't really commercially adopted. It was built for sort of video application, but now 5-6 years ago, when sort of the AI wave starting to hit, not quite as big as last year when ChatGPT came out, but we saw the wave coming. A lot of new models coming out and training technologies. Also with the advent of GPU, people starting to think that, we've got computing power now, like that was 5-10 years ago with GPUs. We can do a lot of complicated models and becoming useful, right? And that was the time that we thought, maybe this technique that Martin, my co-founder, has developed 25 years ago is useful.
Okay.
That was how we came about starting when we were the previous company, and he and I co-founded our previous company. Within that company, we incubated the idea. We started talking to people and see a lot of interest in other people looking for this technology, and then we decided to spin it off and get some funding and get Untether AI going.
Okay, interesting. Yeah, this is so excited. I didn't know this technology was, developed probably years ago until now it's finally commercialized.
Yeah, it was long time ago. This reviving and sort of an old concept. The patent
Mm.
Martin actually had, and his students had a few patents on it. They basically expired. It was
Mm.
too long ago.
Oh my God, this is so excited. So about Untether AI now, is there any new excitements and any big progresses you want to share with us? Because you mentioned about the new projects that
Well, we always have new projects going on. I can't really share a lot about that,
okay.
except that we are always working on new generations. Our second generation device is coming soon. And obviously, when something is coming soon, even newer generation architectures and devices are already in the works. And architecture and development and new ideas are keep pumping out ideas internally. So from a market direction, our first product generation product, which is already out in the market, basically targeting for servers and data centers and whatnot. And we still continue on that direction, but we will also be stepping into automotive, autonomous driving, that area. Basically moving away from the data center cloud a little bit out to the edge, not to the extreme edge, but we have the capability to do that.
Okay.
Well, and Tether isn't a big company, so we have limited resources and budget, so we have to be a little bit focused.
Yeah, sure, of course. Now I'd like to zoom out and talk about the AI and especially chip industry in general. So now we're facing the issue of the shortage of AI chips. So people are
Yeah.
not able to buy H100 as, for example. So this is creating a downstream effect in foundation model training. So would you see this shortage persists in the foreseeable future?
Yeah, I think it will, because the chip capacity thing, although it's sort of eased up as compared to a couple of years ago, but still the AI sort of boom is demanding a lot of compute power,
Mm.
and which actually brings me to the trip that I made back to Hong Kong this past November. I attended a couple other seminars over in that area. Specifically, there's a AI themed and robotics themed conference or mini conference seminar that is around the Greater Bay Area, if you will. Now, I don't know if people know, but in Hong Kong and Shenzhen area, they're calling themselves the Greater Bay Area, kind of mimicking the Silicon Valley Bay Area. So they've got a big technical semiconductor ecosystem there. From that particular conference, I'm hearing over and over again, one of the big obstacle, even over there, of developing AI is compute power, meaning that the hardware is even able to train the models and whatnot. So that is a bottleneck, and capacity is limited in the sense that while the factories, the fabs, and from TSMCs or even the Samsungs of the world, TSMCs of the world, it's not an overnight build, right? So you take 2 or 3 years to build up capacity, and so the demand, if the demand is now, and they're trying to build factories to support those demands, you won't be seeing it now. You'll be seeing it maybe 2 or 3 or 4 years down the road. Japan is also trying to do this 2 nanometer technology. So Europe, everywhere is trying to build up capacity, but they also have to, the foundries also have to be careful about overcapacity, because they would think how much capacity is needed, and they won't really try to dump. It's also expensive too, but even if they had all the money of the world, they won't just spend a huge amount of money to build many fabs, the this whole semiconductor industry, it goes in a cycle. So it always goes in cycles. So if you are reacting to the peak too fast, then the downturn is going to hurt you, because you're going to be over capacity. So people sort of control the amount of capacity. So it's been in the foundry world, the game of capacity control when it's in the peak time, in the sense that peak time meaning that many people are wanting to build chips. Well, right now it's AI and automotive.
Mm.
So those two industries are calling for chips, 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 chips,
Yes,
and
I
and
demand.
then yeah, and then the foundries themselves, as big as TSMC, what they normally do is they won't really try to support um, the two biggest customers or verticals with everything, because they want to make sure that other industries also have enough supply.
Mm.
Otherwise, you're going to squeeze them down and kill them, right?
Yes.
So they have to, in these times, the TSMC, the foundries would have the upper hands, if you will, to control who gets the capacity.
Yeah,
And
exactly.
so that's the ecosystem that you're seeing now. But that to me, that means as much as Nvidia wants to build their H100, TSMC would have their own sort of way to view the whole wide industry, not only AI, but other things. How should I allocate? So yeah, having all that said, I'm going to come back to my opinion of yes, in the next 2 or 3 years, I think there's going to be still shortage of GPU chips.
Yeah, I think founders, especially within AI industry, should be really look into these questions because that can
Yeah.
really influence their product development. And also like another news I've been hearing of like about the chips, so that Apple are pulling out of Taiwan and they're basically putting their money investing into other nations like Southeast Asian, for example.
Hmm.
And also because that Nvidia experiencing the extreme high demand due to the vector pipeline processing, uh,
Hmm.
useful in training the neural nets and that. So it seems like TSMC is possible in trouble. Would you see this true?
No, I don't think TSMC is in trouble in terms of pulling out of Taiwan. Now, I'm not familiar with exactly what their maneuver is in terms of Apple pulling out of Taiwan. But Taiwan pretty much is the only, either Taiwan or Taiwan Semiconductor, TSMC or Samsung are the only possible um, manufacturers or foundries that can support what Apple needs.
Mm-hmm.
Uh, Pulling out of Taiwan could mean two things, because they can build foundries in Southeast Asia, they can build foundries in US, they can build foundries in Europe. When they say they, I mean TSMC, and so they are the one. So TSMC is already building a plant in Arizona. So, but that's kind of a bit delayed. There's a bit of culture workers difference. That will be another topic to discuss. But anyhow, I think building fabs, the facility building out of Taiwan, probably is because the geopolitical thing. It's fearing mainland China is going to do something to Taiwan mainland. So it's safer to bring the supply chain even outside of Taiwan. I think that and Southeast Asia, if TSMC built a plant in Southeast Asia, that's also requires time. But these guys, these are long-term plans usually. So yeah,
Yeah, we'll see about that.
yeah.
Yeah, thank you. Thank you so much about that. Uh, and also a question about chips is Moore's law. So a lot of people are arguing Moore's law in 2023 this year. So as the technology approaches a too nanometer scale with the rising
Hmm.
costs, there are a lot of questions about the feasibility of continuing the trends of doubling transistors counts every 2 years as what Moore's law is determined. So do you think we
Hmm.
should, like we've hit the bottleneck in the computing power? Would you see the Moore's law will still live probably for another 20 years after?
Well, this is you could answer this question in different avenue or ways.
Mm.
The way I think about Moore's law is Moore's laws when it first started describe the I would say I would use the current technology, current semiconductor transistor technology, which is called CMOS, CMOS. We'll not go into the details of what it means, but this is the prevalent technology that all computer chip uses, the types of transistor. And that was, we started using that CMOS technology started back in the 60s, actually.
Mm.
And it's been going on since then. And the scaling, doubling the transistors because the geometry was that yay big back then. Then it's keep every year they do this, do this, do this, do this. Now, in fact, actually, technically speaking, to me, that transistor structure stopped at 28 nanometer. That was the last generation. So
Mm.
technically speaking, the Morse law scaling stopped at 28 nanometer.
Ah,
Because it's 16 nanometer, the transistor structure became different. It's still somewhat similar. They built the transistor differently. So from the beginning up to 20 nanometer, they basically transistor structure is the same. They just make it smaller, 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 smaller.
yes.
Better equipment. And the compute industry, microprocessor being built on these technology. Okay, I can build smaller. I've got smaller transistors, so I can put more transistor in the same area of chip.
Hmm.
And that trend has been going on until 20 nanometer and 20 nanometer-ish, starting to get the difficulty, can't scale anymore because it's just too small. So they actually have to switch to another transistor structure, which is sort of like a CMOS, but it's similar function, but a new name. We've given them a new name called FinFET. If you don't know if you heard of the name called FinFET. CMOS actually is CMOSFET. So in short, it's called CMOS. But now they've changed to a different structure called FinFET. Um, it's operating somewhat similarly, but this transistor structure is different so that they can build
Hmm.
up 16 nanometer, 7 nanometer, 5 nanometer, even 3 nanometer with the same structure. But 2 nanometer, they are moving to another transistor structure.
Oh, so they basically did a whole revolution in terms of hardware.
It's sort of where, yeah, the way the build the transistor is different.
Hmm.
At 2 nanometers, called gate-all-around transistors.
Yeah.
And then there are still 2 or 3 more different types of transistor structures that's coming down the pipe. 1 nanometer, point 0.7, 0.5. From a research perspective, researchers is already looking at those transistors. So people are trying to push Moore's law like the best they can from research perspective by not really now only shrinking the size of the structure, they're changing the structure in order to keep up with the Moore's law. So to me, it's kind of not technically the same Moore's law, but the effort of doing that kind of research and making different transistors so that they can do smaller geometry uh, is already, yeah. To me, it's already like, well, I wouldn't say more than more because there are people talking about more than more, but perhaps you can categorize that. I don't know if you've heard about more than more. This more than more is saying that okay, we don't really have to. The Moore's law is not the only thing that gives us advanced technology. We also have other integration of analog functions, sensors,
Hmm.
edge, IoT, this type of different way of advancing the semiconductor industry and technology. The Moore's law, people talk about Moore's law because most people think about compute power.
Hmm. Yes.
And at the compute power from one chip, basically, is people think about within that chip, how much compute power you get. You squeeze more and more transistor, you can do more and more. But now, because of this um, newer technology, 16, 7, 5 nanometer, as you already talked about, the manufacturing cost is really expensive back down there. The industry actually is moving towards instead of integration. When I say integration, it means putting more and more functions in a single chip.
Hmm.
The industry actually is reversing that order. The industry is moving towards disintegration, meaning that you built a specific function. For example, AMD has already done that, Nvidia has already done that, where they have their Zen core, just a die, a small die for Zen core. If you would pick, if you want to, if you do 8 of those cores, you just plug 8 of those chiplets, and using packaging technology, more advanced packaging technology, to put multiple dies, multiple chips into one single package, including other functions like memory and whatnot. So this is disintegrating from a single chip approach to a multi-chip approach, and in the industry we're calling them chiplets.
Hmm.
And now that actually opens up a whole new avenue of compute architecture development, meaning that you can mix and match. You can mix and match a lot more flexibility, mix and match different things into a single package. That, but and also 3D packaging,
Yeah.
stacking devices on top of each other. So that actually opens up a much wider innovation and performance improvement options for chip companies, semiconductor companies, to produce better performing products, not only by the semiconductor technology, chip technology itself, the process node itself. Because the process node itself, even though there's a roadmap for another 5 generations, probably from a research perspective, your investment versus return ratio, the ROI, is not getting better. Because this gets a lot more expensive, but each generation, you're probably only getting 20, 30% better in performance.
Got it.
But you spend a lot of money. Those are the big guys' game, basically. Like
Yes.
the Apples and the Qualcomm, they've got the money to play the game. But for a lot of people, there's more there are other types of innovation techniques like 3D packaging, and even higher level at the system level, heterogeneous computing is getting very important, meaning that you're not only optimizing the compute chip itself. You have to optimize in order to get the high performance AI sort of system. You have your CPU, you have your GPU, you have your specialty chip, you have your AI accelerator chip, you have your memory, you have your storage. How do they work together to make the whole system faster? If you're focusing on only one, let's say AI accelerator chip, then you're only optimizing that particular area and you're forgetting all the others. So there's yeah, the advancement opportunity is wide open. So to me, it's a very exciting time. I wouldn't worry too much about the Moore's law, whether it kind of sort of gets bottlenecked or not,
Yes.
because looking at Moore's law is only one small, very focused aspect.
Ah, okay. Interesting. Because I always thought Moore's law is really important in terms of the whole chips industry. So when I saw
Yeah, it's been important for the past 40 years because people in retrospect, maybe I think it got the whole innovation sort of community a little lazy, because they knew that next generation I've got a better technology, so I'm just going to move to the better
yes,
technology, right?
exactly. That's exactly how people are feeling about that.
Yeah,
They say we should probably get into market later as the chips are cheaper and faster, better if we start to
yeah,
do this year.
yeah. So now to me it's exciting because people are starting to think, okay, now I can't really get a lot of if you move down to 3 nanometer or something, it's very expensive, and
Yes,
I'm not really getting a lot in return. So what can I do? What else can I do to push the boundaries, right?
yes, exactly. Okay, also Raymond. So I'd like to also talk about some of your investments histories and your experience.
Sure.
You're a founder and also angel investor, as you mentioned, you're regular doing investing now. Tell us what you're looking for in a company you're investing in.
Um, I generally invest in tech company, and recently more back into looking at deep tech and hard tech. But regardless of what type of company they'll look into, my investment thesis, um, one, not the single, but most important thing I first look at the company is are the founders.
Hmm.
Um, Single founder versus two founders, three founders make a difference. I prefer companies with multiple founders, two or three.
Hmm.
Three probably do being a good optimal because when you build a company, it's kind of hard for one person to have all the skill sets
Yes.
to get going, right? Perhaps I'm biased with my own example. I've always had co-founders, and just an example, Untether AI, we started with three co-founders with different skill sets. We are all kind of techie people, but myself is the silicon guy. So I bring in the silicon implementation experience and supply chain and how to build a chip, that side of thing. And my co-founder, Martin Snellgrove, is the genius of the house. He's the brain behind the architecture and the math and the his overall view of everything. And my third co-founder is Derek. He is the software guy and the AI ML guy.
Hmm.
So from a technical perspective, we have everything covered because we understood early on that building a chip company, it's not just hardware, it's heavy, very heavy software, and also the AI sort of stack, software stack, how to build that stack perspective. So that to me, well, I mean, both Martin and I and Derek had entrepreneur experience before. So we had started companies, we had ran companies, looked dabbled a little bit into sales, finance, but we all kind of basically are sort of engineers first, but we have other experiences.
Mhm.
So that type of combination of different, also personality difference too. So so the personality needs to be complementary, and also how long have the founders known each other? That's also important because you want the founders to be working harmoniously, know that
Oh,
they can work together, right? It's
yes.
hard sometimes. It is a bonus if these are kind of partners for a long time, has done things before, like me and my co-founders. I've known Martin for 20 years. Martin has known Derek for yeah amount of time, quite a long time. I haven't known Derek for a long time, but there is this trust and thing going on because we know each other, the
Huh.
style of each other. So that becomes a stronger bond as a founding team. That that doesn't always happen, especially when you're a young founder. Uh, but again, I guess that's the advantage of older founders, where you've done it a few times and you have a partner sort of in crime for a couple of times. Then you do another thing together. That to me is a pretty strong indicator of investable company. Obviously, the technology behind it has to be strong and solid, and the product has to be strong and solid. But it's the founders' relationship, whether they have complementary skills, whether they are passionate enough to and determined and decided or um, committed enough to run the path when they've set the goal. Are they persistent? Are they really really want to do it? Kind of thing. Although that's a bit tricky in the sense that you also want the founders to be able to realize that they are walking the wrong path and be willing to pivot.
Yes.
Right. So,
Exactly. Like startup requires a lot of elements, even luck to
oh,
make
sure.
work well. And I think that was really inspiring in terms of you mentioned the connections between the two founders, because sometimes investors need to think about the startup operation side. So I can definitely tell you're a founder and investor because you know how are they working together, what kind of questions can be raised, and also what problems that they may be facing.
Yeah.
Yeah. So is there any you would consider successful investment experiences that you want to share with us? Because I did, you know, you mentioned about some of the company you invested in had
Um, Yeah, I've started, as I said, I've started more somewhat regularly investing in startups maybe 3 or 4 years ago.
Yes.
I've built up some small portfolio, but none of those really has had a successful exit yet.
Mhm.
Now, I also told you that I had actually done some startup investing like not so many years ago, 8, 9 years ago, a
Mm-mm.
few of them, and actually one of them did exit pretty nicely, and it IPO'd last year. It is a semiconductor company, and back then I only invested in the company I knew, very familiar with. So I invested in this company at a little convertible note. It was strategic, and the reason why they're not really after me and my partner's money, but more the relationship. There is some, because I'm in the industry, my partners are in the industry, they can help each other. There is some strategic value that they allowed us to hop on the ride. And back then, I thought they had the very good technology. I've met the founder. There is some attraction to the company, partly because the founders are, I think, all the founders are Chinese, and one of them is actually from Hong Kong. So there's that kind of like, because I'm from Hong Kong, right? So that's that relationship there, and I really like their technology. I won't go into what kind of it is a deep tech
Sure,
kind of
sure.
a company, and so I saw them sort of gradually. It's not an overnight success. Saw them uh, inching along a Series A, Series B, C, D, D extension, E extension, pre-IPO kind of a bridge, and then finally IPO'd. So I've got a pretty decent exit out of it. I still hold some of the stock there, so the stock has almost doubled since IPO'd. So it was great ride.
Yay. Congratulations about that.
Yeah, thank you, thank you. That was that one. Still far, I'm still a one-hit wonder from a investment perspective. The other investments, I'm still kind of looking. There's some promising ones, but none of them has exited yet. But I mean, this is a sort of a relatively long game to play, right?
Yes,
I don't
exactly.
expect.
You can really expect early access in venture capital. It's a long-term game.
Yeah,
Also, within the role, you support founders, and that's also the excitement to help
yep,
others change the world as well.
for sure, for sure. Yes, that's kind of what I enjoy doing too. Like sharing what I can with younger founders, with experienced founders. I can learn from them too. So it's two-way street.
Yeah. Yeah. Thank you so much, Raymond, for doing this podcast with me. Uh,
No, it's my pleasure.